Hello everybody, and welcome to another aga-cad webinar. Today we will present you how aga-cad opening speeds up and simplifies the opening creation and management workflows in Revit. Today's agenda will cover three main areas. The first one will be opening creation possibilities. Then we'll move to the management of an already created openings. And to finish with, we'll go with opening sharing, scheduling, and dimensioning. Before I go into Revit, I'd like to introduce myself and our company. My name is Aleksandras Sheja. I'm an HVAC engineer, and I started my practice in 2014, gaining experience with ventilation, heating, air conditioning, and the heating pipeline design. Now, for the last 5 years, I have worked as a BIM application engineer at aga-cad, being responsible for the MEP-related tools such as CAD opening, smart browser, MEP hangers, their development, implementation, and technical support. And as a company, aga-cad is an authorized Autodesk developer that has a wide range of applications for Revit with useful features for complex and specific workflows. Our history started already more than 30 years ago, and now we are also part of a global digital transformation leader called Archons Group. Our main focus of development is in three areas. Those would be modeling, documentation, and data management. Our key goal is to help Revit users to improve their workflows during the BIM processes. And we do this by eliminating unnecessary tasks and securing accuracy in Revit models. This saves vast amount of time and lets our users to focus on tasks that usually create value. Our portfolio consists of products that can be used by users from different disciplines. That would include the wood framing solutions, metal framing, precast concrete design, and MEP-related tools. So today I will be focusing on one of those, and that is CAD opening. And let's go to the presentation itself. Let's start with the opening creation. With native Revit functionality, it takes a pretty long time to create and size the openings correctly. The size vastly depend on quite a few factors, those being type of project, company who's creating the openings, or country standards, and also on the types of structures that have to be cut, and the types of MEP elements. Let's see how the CAD opening deals with that. Let's go to the model, and at first, a short introduction into aga-cad doc is due. To use any of aga-cad tools, please go to aga-cad.com webpage and download the doc. Once installed, it will appear in a separate tab. There you can control its visibility. And once on, you can trial any of our tools or activate your licenses. Once the tool is activated, or you have a trial, you can click on the tool in the doc and use it there, or with this button, add it to your toolbar. That's what I will do for this webinar, and I will use it from the toolbar, closing the doc. Okay, and here we have a simple air conditioning model with some additional pipes added at the bottom, and the architectural model that is currently linked. But that would be too easy to insert openings into just one that's such small model. So let's make it more interesting. At first, we will add electrical model containing a cable tray that usually requires an additional offset from the top of the element when the openings are being created. And the second link will be of the ductwork model, as it is hard to imagine one system requiring more openings than the ductwork. Now we're a bit closer to what we can see in a part of a regular model. Designing openings by hand in this case might take me about half an hour, maybe less, but that would depend a lot on how precise I want them to be and whether those need different offsets depending on the system, wall type, overall dimension of the MEP element. So let's compare that to the cut opening and imagine the scalability. We'll do the insertion of openings in 3 stages by the order the models were opened. Also, since the architectural model is linked, currently we will be inserting the opening placeholders that, spoiler alert, can later be inserted to the architectural file as the real void openings. Let's start with the pipe openings. As you might have noticed, there's a bunch of regular pipes in this project connecting the air conditioning units. Those pipes are close to each other, and it would be the best to create a single opening fitting both of those. But there are also those additional pipes on the right representing the possible different sizes that could be used in different sizes that can be used in projects. Let's click on Insert Openings. And in this table, we have a list of all available openings for the pipes in the current view. We can see them in pairs to know which cutting element is crossing which structure, as well as we can filter this table to create only the openings of our choice in one run. The filtering can be done by any parameter from MEP or structural element, and we'll start with the opening insertion for the pipes of larger sizes. I could either locate those in table by the pipe diameter parameter, or use the cut offset parameter that is currently visible in the table. I have already applied cut offset to these pipes, so let's find pipes with a bigger cut offset and isolate those, insert openings for those. As you can see, it took less than 1 second to process those, and we get a precise result with exactly the offsets that we have required depending on the pipe size, starting from 10 mm for the smallest pipe and going all the way to 40 mm offset for the largest pipe diameter. That is a part of the answer of how flexible the cut opening can be. The offsets can be preset not only depending on the pipe size, but also depending on the system type. Because as we know, for example, the hydronic and the sanitary pipes are not exactly the same thing regarding the openings. Now let's quickly insert the openings for the remaining interferences. Those leftover pipes are close by, and in my configurations, I said that if openings are less than 50 mm apart, they should be automatically joined. Let's see how it goes. And the result is as expected. We have 17 new openings that were joined automatically, so we don't have to worry about that. Pretty simple. Well, we've spent already more than a minute on pipe openings. Let's move further and insert the openings for the cable trays that come from the linked model. Here, I'd like to speak about the additional control that you gain with the cut opening during the insertion process. Previously, we have filtered openings to be inserted by the predefined offsets. Now let's do something more solid. As I mentioned, it is possible to filter by any parameter of the MEP or structural element. That includes the type of the structure, would it be a wall, floor, structural framing, or by level on which structure is based. Or the one parameter that quite often comes to mind, the fire rating of the wall. I already have added this parameter to my list to be visible and added to the grouping so that in the area on the left, I can filter by this parameter as well. It is enough to expand the tree, click on the parameter, and filter out what you need. In this case, it will be a 1 hour fire rating. Now that this is done, we can choose to either insert a different type of opening, maybe the one containing fireproofing elements, or we can simply add an additional offset for these cases. Let's make the offset be 50 millimeters and change from the standard one. We can remove filtering now and insert all the openings for the cable trays. That will take a second. And let's check the result. From the go, you can see that some openings are larger. The easiest to review place will be closest to us. Here in front, we have a smaller opening in front for the non-fire rated wall, and on the back is the larger one. That larger one became even larger than expected because somebody modeled fitting into the wall, and the cut opening had to accommodate for that as well. But don't worry, if that is needed, you can tell our tool to ignore places where fittings clash with the structures. Also, if it ignores those, you can choose to see those places without inserting the openings. Further, with cut opening, you can achieve even more. For example, here I have set additional offset for the cable tray opening on top so that the cables would fit. That's a regular practice. Okay, finished with cable trays, let's move to the ductwork. That one sure will take longer. Here I would want to change the view of the model to focus on a very specific location. In this location, there is a lot of MAP elements crossing the structure in close proximity to each other. Let's see how the cut opening deals with that. And while it's opening, I want to remind you that the pipes are in the current model, while ducts came from a different link. This time we will not do any filtering, just resize the table to have a better view of the Revit screen. This time it's around 21 opening being inserted, but also cut opening will compare the distances between the new openings and the ones previously inserted. And if I will require it, the openings will be joined. Doesn't matter where the MEP element came from. And you can see that now in the model. 21 opening being inserted, and the opening which was previously there is now joined with the new one. So in overall 5 minutes with comments and less than 10 seconds of actual insertion, we have covered whole part of this building. All that is scalable, as the cut opening can insert thousands of openings that automatically fit all the set standards in minutes instead of spending days on the project. So, with cut opening, you can save time on multiple opening insertion during the whole modeling process. You can be flexible with the opening that will be inserted, configure those to any standards, and later even share those configurations with your colleagues. And if the insertion process is automated, that removes the stress of checking every intersection, as well as it reduces the chances of the openings being missed. Going to the second part, the management of an already created openings. Model changes are an inherent problem of modeling. Well, it's kind of modeling is a constant process of changes, and it's not a one-time job, isn't it? But how do you find all the changes without the tracking tools? It is possible to use Navisworks or Autodesk Construction Cloud, but is that convenient enough? Let's go back to the same model and do some changes. Firstly, pipes at the bottom look off in this model. We should delete those. Just select and delete. Then let's move the pipes from that are connecting the air conditioning units. So not a lot of changes, and these changes would be easy to catch as we just did those in the model and we know which openings to change. But what if we have bigger problems? To receive those bigger problems, let's reload the duct link with a changed ductwork. And after it's done, were you able to catch what has changed in this model? If you're used to coordination, you might have just noticed the subtle changes. Small hint, there are 5 changes in ductwork model. But here it is still easy to do that since the changes since the model is small. Imagine the large models with thousands of openings. Specifically for such cases, we have the opening revision functionality that collects information about the changes and presents them in a single place. Let's go at first with the pipes again. The tool says that there are some cutting elements missing. So let's select those. Those will be the deleted pipes. And let's update the openings. You can do that by clicking on Agree with Last Changes. Now going to the other pipes, and those will be under the unjoin. And those are the pipes that we have moved. The cut opening has at first to unjoin the opening to know and find out and know the new location of two openings for the two separate pipes that, if they fit the criteria, will be joined again later. So that's exactly what happened. Now the duct changes. If you've noticed those, you're really good at coordination. Firstly, we'll deal with the size changes that were the most visible. Overall, 3 openings will receive their updates. It's those 2 round ones and 1 rectangular. Agree with changes, and we have new opening sizes. But there is still one change, said changed position. There are 2 openings. One of those openings can be seen in the center of the model, but what about the other one? It's not as visible. With cut opening, you can easily find such hidden places. This duct not only changed its location, but also the angle of penetration. Cut opening will deal with that. The adjusted opening will fit all of the pipe and add the offset according to the predefined configuration. And that's all from the revisions. It barely took me a minute to find all the changes and make sure that the model is up to date. So what you get with cut opening is certainty that no change will get past the revision, and you will have an easy way to deal with those changes. Just like that. Now going to the last part, additional data and sharing. What else would be needed from opening after they are already placed in the model? The answer is information. How about also sharing that information with other trades? And as a cherry on top, the automated dimensioning. Back to the same model. For the convenience, our opening families come with the additional parameters that contain information that can simplify future work with those openings. Let's take a look at one of those openings. Here you can find such information as mark that is assigned according to the system, opening shape, elevation, host information, systems to which the opening belongs to, who inserted it, and when, as well as some accepting and declining parameters. For the joined openings, the information is not gone. Cut opening combines the information about the systems going through the opening and opening's dependence. As you can see, the marks are combined and the systems are all together. Let's see how that would look like in a schedule for this part of the project. And in the schedule, we can see a list of all openings that were inserted just a few minutes ago. If you need more information, cut opening can copy any parameter from the MEP or structure to which the opening belongs to, so that you have all the needed information at your fingertips. Another big job, of course, is the dimensioning of openings. And that's where the smart dimensions comes to help to save even more time. Let's go to the level view. Smart dimensions can be used not only for the openings, but in this case I will show just on those. Let's do a quick task. How to measure openings to the closest parallel wall. It takes a lot of time to figure out which wall is the closest and when we need to create the dimension. Selecting one, choosing, deciding, placing the dimension. But we can do it in a faster way with the smart dimension. It will take seconds to measure all the visible openings to the closest walls. Those can also be grids, columns, or any other element. Opening to the opening, opening to the door, window, whatever you like. And being able to automate such manual tasks gives freedom to spend time on more valuable jobs. It took smart dimensions just a few seconds to find and place all of the dimensions. All that is left to do now is to move them a bit to make for a more presentable view. Just a few clicks. Additionally, this functionality, as I mentioned, can be used not only on openings, but for any other elements in your project. And let's finish with the dimensioning. Let's go to the sharing of the openings. For that, I will come back to my 3D view. And after the openings are already modified, placed to new positions, let's export those. For that, we will use again the opening revision, get the same table of all of our openings, and we can click to export those openings as a separate file. That file later can be sent to another engineer, architect, or used for coordination. And let's just imitate that. I will go to the architectural model. It's the same one that was linked. And let's insert the same openings that I've just exported, that are already modified, even though the MAP is missing here. Let's add them, but with one change, let's insert them as voids in this case, because we can already cut the architectural model. And as easy as that, all 30 openings are placed. Additionally, we have one more tool as cut opening. It's called cut opening free. Not very surprising. What the difference is, cut opening free is free of charge, and with it, you can share opening information with people who did not purchase full cut opening version. By default, free cut opening version can create openings only for the elements that are in current project, so walls and MAP elements have to be in the current model. But if the openings were created with the full cut opening version and exported, you can send that file to the person who uses cut opening free, and he will still be able to insert all of the same openings in their model. The only limitation is that with cut opening free, he will not be able to make a revision of those openings or export them and send them back to you. But still, there is a road of communication between the engineer who is creating and managing the openings with the people who would need to insert those. Additionally, these openings could be inserted when all the models are linked. So if I would link architecture, MAP, I could still insert the openings. So, as a conclusion of this chapter of the presentation, the information in the openings is conveniently filled, so you always know to which system opening belongs to, and it's easy to track those. You have a possibility to share those openings with other trades or with your colleagues for opening coordination. And cherry on top, you get a fast dimensioning, but not only of openings, any of the models depends on how swift you will be with the configurations. So, some short takeaways. With cut opening, you can save time on both opening creation and coordination whenever the changes occur. And you can actually locate those changes so you are sure that you are not missing any of those. You will have all the data needed to work with the openings, and you will speed up all your dimensioning processes. That will be it from the main part of the presentation. If you want to try cut opening for free, please go to aga-cad.com webpage, and there you can download aga-cad doc as I mentioned. Just be sure to take a free trial of the full cut opening version, not the cut opening free, as that has some limitations, as mentioned. And if you want to automate your workflows in any other area, would it be hangars, creating Revit family libraries, framing, precast concrete design, element placement in models, repetitive placement, book a personal meeting to see how we can help you. And that will be it from the main part. If you have any further questions or questions during the trial, feel free to contact us. Good luck with opening creation, and have a nice rest of the day. Thank you for your attention. and bye-bye.